Ladies and gentlemen, dear guests, good morning everyone. Welcome to the Advanced Computing Portugal 2030 meeting. My name is Daniel Silva and I have the pleasure to guide you through today's program. Thank you all for joining us today. We value your participation and feedback. During the meeting, you may submit questions online and we will answer during the discussion. Therefore, without any further delay, let me welcome on stage for the opening moment the Rector of University of Minho, Rui Vieira de Castro.
Dear Minister of Science, Technology and Higher Education, Professor Manuel Leitor, who is following us online, dear Mayor of the City of Guimarães, Dr. Domingos Bragança, dear Dr. Khalil Ruana, Deputy Director General for DJ Connect of the European Commission, dear Professor Nuno Rodrigues, Coordinator of Encode 2030, and dear participants in this seminar on Advanced Computing Portugal 2030, Progress Achieved and New Challenges. Welcome you all to the University of Minho. A few brief words about this seminar and the meaning it has for the University of Minho. In 2017, Minho Advanced Computing Center, MAC as we call it, was established within the framework of a memorandum of understanding involving the university, the Foundation for Science and Technology, and the University of Texas in Austin. MAC is a national collaborative infrastructure to promote and support open science initiatives and advanced computing, data science, and high-performance visualization. This implies a commitment of our nation through MAC and our advanced computing network aimed at strengthening the support for traditional research areas and to ensure the development of new lines of research that operate with a large volume of data. It aims also at promoting an infrastructure with a determining role in the organization and coordination of research activity and development in advanced computing. It also aims at ensuring links with international structures and entities, and finally it also aims at promoting economic activity in areas of data intelligence. 2018 saw significant advances in the establishment of MAC. On that occasion, Minho and FCT signed a protocol that made it possible to install a MAC visualization unit in Minho, including the human resources associated with this operation. The first visualization center for the Bob supercomputer was installed in 2019 on the Walter campus of the University of Minho. Meanwhile, last November, Portugal signed in Strasbourg the contract that will allow hosting the Eucalion supercomputer under the Euro HPC initiative, thus reinforcing the MAC's capacity to the petascale level. Minho has therefore played a central role in this strategic project in our country, which is decisive in supporting and promoting the challenges of the ongoing digital transition. The supercomputer, and now mentioning the specific case of the University of Minho, has also been enabling our own scientific community to develop new lines of research. The upcoming installation next year of the petascale machine Eucalion at Ave Parque, Guimarães, and I must thank the municipality of Guimarães and Dr. Bragança for its continuous support, is an excellent opportunity for reflection on the path taken so far, both in terms of development of the project and the levels of use achieved. It is also an adequate moment to boost the Portuguese participation in the Euro HPC Joint Undertaking Initiative. The University of Minho is strongly committed to MAC, and for this reason, the institution is available to assume new responsibilities in the context of the installation and operation of the new supercomputer Eucalion, which we all believe will contribute decisively to to a greater involvement of our country in science and innovation activities of excellence involving calculations and very demanding data processing. Thank you very much, and a good seminar to you all. Thank you.
Obrigado. Thank you, Rui Vieira de Castro. Agora tempo de chamar ao palco o Presidente da Câmara Municipal de Guimarães, Dr. Domingos Bragança, para o seu discurso.
Muito bom dia a todos. Eu vou falar em português, o meu inglês não é muito bom, portanto, eu sei que esta sessão é em língua inglesa, mas permitam-me exatamente esta apresentação em português. Sr. Ministro da Ciência e Tecnologia, Manuel Heitor, Mr. Diretor-Geral, Cali Barruana, Director Management, Cali Barruana, good morning. Sr. Reitor da Universidade de Minho, professor Rui Vieira de Castro, Sr. Vice-Presidente da Fundação para a Ciência e Tecnologia, professor Nuno Rodrigues, cumprimento todos os participantes deste seminário de apresentação do Centro de Computação Avançada aqui no Hub Park, Universidade de Minho, fazendo parte de toda a rede europeia de computação avançada. A minha mensagem é simples. Guimarães, a Câmara de Guimarães, tem estado nos projetos da Universidade de Minho, neste caso também da Fundação para a Ciência e Tecnologia, todos os projetos que robusteçam a produção de ciência, de conhecimento, e que nesta produção de ciência e conhecimento a sociedade, e aqui a sociedade bimaranense, mas todo o território desta região, saia mais robusto, mais capacitado, isto é, as pessoas e as empresas. Guimarães afeta ou afetou cerca de 80% dos fundos comunitários para projetos em infraestruturas, em requalificação de espaços, em projetos para ceder à universidade e às diversas entidades de ciência e de tecnologia. Eu repito, 80% dos fundos comunitários que Guimarães captou neste programa 2020 foi afetado, alocado exatamente a projetos com a Universidade de Minho, com projetos com as entidades de investigação científica e também com o Instituto Politécnico do Cábado e do Ave. E Guimarães continua a abraçar com entusiasmo, com convicção, os projetos que temos para o futuro. Este é um projeto que liga Portugal, aqui do norte de Portugal e da região do Minho, liga à rede europeia de computação avançada. Este projeto é infraestruturante para tudo o que nós fazemos, quer universidade, quer investigadores, ciência, quer empresas, quer cidadãos, exatamente no mundo de amanhã, que já é de hoje, do mundo obrigatoriamente que a revolução da ciência e da economia e da sociedade nos traz, que é o mundo digital. Sem superestruturas destas, nós teremos muita maior dificuldade exatamente nessa digitalização da economia e da sociedade. Mas nós continuamos a ter um conjunto de projetos ligados à ciência e tecnologia. É bom que aqui reafirme projetos de tamanha dimensão, como é a Academia de Transformação Digital, que temos em curso, como é a instalação da Engenharia Aeroespacial, que temos em curso, num dos edifícios que será emblemático da cidade de Guimarães. E para também completar este esforço, e também numa abrangência grande com outras instituições, temos um grande projeto que é a Escola Hotel, com o Instituto Politécnico do Cábado e do Ave. Mas como nós sabemos que ciência e tecnologia são potenciadores do nosso futuro e que nós queremos que o nosso futuro seja eu utilizaria a palavra, se calhar errada, como num processo de osmose entre ciência, tecnologia e cultura. Nós estamos a acabar a terminar um dos grandes projetos, exatamente da área da cultura, que é o edifício do Teatro Jordão, da Garagem e Avenida, exatamente no campus de Couros da Universidade de Minho, que alocará ou instalará as artes performativas, a escola de música e as artes visuais da Universidade, da Academia Conservatório de Guimarães. É isto, ou melhor, é este conceito que nós temos de sociedade. Uma sociedade baseada no conhecimento, baseada na ciência, baseada na cultura. Mas esta base é o suporte de uma comunidade de cidadãos informados, competentes, capacitados, que assumem a tecnologia e o conhecimento para que possam desenvolver a sua sensibilidade à beleza e à estética, para que possam ter a compaixão necessária para darmos as mãos como humanos e construirmos um mundo melhor. É nesta base que a Câmara de Guimarães apoia e quer ser sempre parceiro das nossas instituições de ensino, nomeadamente do ensino superior e das instituições de investigação científica. É exatamente por isso que consideramos um dos principais ativos da nossa região, se não o principal ativo da nossa região, a nossa universidade e os nossos institutos de ensino e de investigação e de ciência. Vamos continuar neste caminho, porque achamos que este caminho é o caminho certo. Sr. Ministro, está-me a ouvir com certeza, nós estamos com estes projetos, mas sei que o Sr. Ministro não é leitor, também estará sempre atento ao que Guimarães e a nossa região precisa do Governo. Eu sou dos que nunca peço nada, apenas mostro evidências do apoio necessário a dar pelo Governo e pela União Europeia. Um bom seminário para todos. Obrigado.
Thank you very much, Dr. Domingos Bragança. And now by video call, Portugal's Minister of Science and Technology and Higher Education, Mr. Manuel Heitor. Please join us. We can hear you. You need to put your microphone on, please.
Peço imensa desculpa. Bom dia a todos, uma desculpa por não estar presencialmente convosco por razões óbvias, mas certamente podemos usar hoje a tecnologia, até porque estamos num contexto de computação avançada. Não posso deixar de agradecer à Universidade do Minho e ao reitor Rui Vieira de Castro a organização deste evento e a disponibilidade da Universidade do Minho sempre para colaborar em tudo o que são formas avançadas de olharmos para Portugal e para Portugal na Europa, assim como certamente a mobilização do presidente da Câmara Municipal de Guimarães, com quem temos tido o privilégio de partilhar ideias e, para além de ideias, implementar práticas. Também todos aqueles que se têm dedicado à computação avançada, certamente antes e sempre aos cientistas, aos utilizadores da rede de computação avançada, mas certamente ao pessoal da FCT, da Divisão de Computação Científica Avançada, da chamada FCCN, à equipa de João Nuno Ferreira, que ao longo dos últimos 30 anos desenvolveram uma capacidade crescente, sempre com novas ambições, e é isso para que nós queremos sempre fazer mais e melhor e estarmos a evoluir. E se a área que evoluiu em Portugal é a computação avançada. Uma palavra também especial ao Rui Oliveira, diretor do MAC, do Minho Advanced Computing Center, e certamente ao António Cunha, que sei que está na audiência, e também felicitações pelas suas futuras funções, e é bom que esteja seriamente mobilizado em também agora o Norte poder cada vez mais ter computação avançada. I will turn to English and let me also acknowledge the contribution of Khalil Rouhana, the Deputy Director of DG Connect, which has been an active friend, I will say, of Portugal in all the aspects associated with advanced computing, among many other in the area of action that DG Connect has been always a partner of Portugal and Portuguese institution. Khalil has also worked a lot with Carlos Moraes Pires, another Portuguese in the Commission that now is in the office of Commissioner Maria Gabriel, and the two of them has been particularly active in helping and discussing the current Portuguese strategy of advanced computing. And I would like essentially to start with that. The organization of this meeting is certainly oriented towards the future. And the future, the way we should evolve in the years to come can only be done with an active participation of all of those actively associated with advanced computing users in general, and essentially with the ambition to do more and more. About 3 years ago, in 2017, Portugal was one of the 9 European member states signing the so-called Rome Declaration, which I have the privilege to sign representing Portugal, with the ambition to provide Europe with a new infrastructure for advanced computing. And we should acknowledge that by that time, the criticism throughout Europe was enormous about the way we should put together a strategy, particularly in terms of the existing European capacity, about the enormous implications on the economic incentives, about the competition between large monopolies in the United States and in Asia against European firms, but also about some criticism about the needs of advanced computing. And it is clear today for all of us that we are in a fast rate of change of the way societies and the economy in particular requires computing power that we need more and more to speed up this process. And in particular, the vision that Khalil has tried to implement in order to be able to do what now we call a joint undertaking, the European High Performance Computing Joint Undertaking, has been a particularly innovative way to bring together different European actors, different European member states, the Commission, but also national and regional governments. And I should note that it has become particularly innovative because of the way we can articulate European funds under centralized management and European funds of decentralized management, particularly European structural funds. We know that is a big path also in the coming framework programs of 2021-27, and in fact, the Euro HPC joint undertaking has been implementing new ways to articulate different European funds. And without this capacity to articulate public and private, but essentially national and European, and within European centralized and decentralized fundings, we will never be able to put together a joint European strategy. Certainly, within this European context, we have also our own strategy, and again, I should acknowledge all of those that over the last 20 years have been able to show the importance of advanced computing, and in particular on the last years to position Portugal. As you know, what we have done about 10 years ago, we very much strengthened advanced computing in different lines of action, and very much starting with the distributed and cloud computing, with a major infrastructure, as you know, which is located in Lisbon at the Civil Engineering Lab, LENEC, with poles in Minho and Coimbra, and then the open up and expansion to other technologies, particularly in Coimbra, in the Lab of Advanced Computing, and more recently in Évora. But the idea we know, and our strategy has been always not to concentrate in a single technology, but open up to different technology, including high-performance computing. So in parallel with developing the national network of the distributed computing, again, with the headquarters in Lisbon and the other advanced computing in Coimbra and more recently in Évora, we have decided in close collaboration with the University of Texas at Austin and within the context of do TI in Portugal program, and the collaboration which again started in 2007 with the Texas Advanced Computing Center, we have negotiated the transfer to Portugal of a set of advanced computing racks, essentially, as you know, 40 racks of the Stampede 1 supercomputer, which was installed in Ribadave in the REN and the NOS installations, essentially in a way to help building capacity, not only in running, but in adapting people to the use of these new tools, and again, to open up different technologies for high performance computing. Actually, I was particularly pleased to see the numbers for the usage of this, and I would like, first of all, to recognize all of those at FCT and Nuno Rodrigues as well for expanding and making sure the operation went particularly well. Over the last year, we have multiplied by seven times the number of core hours being used at MAC, and therefore this has been a very interesting achievement in the use of this computer, which was certainly transferred to Portugal under this large framework we established with 2000, and we know that in the years to come it needs to be replaced, but again is giving step by step, is avoiding spending science money in buying buildings of land, but essentially with a partnership with Austin, a partnership with major Portuguese companies that we have been able to try to do our best with existing capacity and always concentrate all our effort in the ultimate goal of the developing scientific knowledge in these areas. It is also interesting to understand that the type of users range from fluid mechanics applications to plasma physics, advanced materials, biomedical applications, and we hope more and more we enter into business-related applications, particularly in the energy area, but also in the telecom area, where major operators in Portugal do require more and more the use of advanced computing facilities. It is within this process of building up capacity, building up international linkage, because we should know where we are, and also our relation with not only the American partners and Texas in particular, but also within Europe, and within Europe certainly with the Barcelona Supercomputer Center, that we need to plan step by step. It is also interesting to note that over the last year we have multiplied by 7 the utilization of the Bob machine at MAC, but at the same time we have kept the use of the cloud computing facility, the INCD in Lisbon, Coimbra and Minho, and also increased by a factor of 30% the LCA, the computing lab in Coimbra, and we still don't have update results, but I hope also to see a gradual increase in the utilization of the Évora facilities. So we see that we have diversified the type of technology, we have open access to different technologies, but we are now able to certainly within Portugal to have an increasing utilization of these different technologies. At the same time, we increasingly participate more and more in international collaboration in Barcelona with BSC, but also with other European partners. And so it is in this gradual and progressive development of our capacity, but also creating markets, scientific markets, but also business markets, that we have launched a further challenge within the European Euro HPC initiative to introduce in Portugal our second supercomputer machine at the level of a petascale machine, able to perform about 10,000 billions of operations per second, and António Cunha has nominated this machine Decaulium. I'm sure you will explain one day why Decaulium, but you know, people like all these names, particularly these Greek gods, to certainly inspire scientists and entrepreneurs to do more and more. So now we are in the plan to set up Decaulium, and the decision was also to use the Minho Advanced Computing Center to expand from Ribadave to Ave Park to put the new machine. Probably in the years to come we will phase out Bob and we phase in Decaulium, and it is within this context that it is important to understand this overall set of different machines in Lisbon, in Évora, in Coimbra, in Minho, in Porto, within the national network of advanced computing, and integrate as much as possible within the Iberia network of advanced computing, and certainly in the European network of advanced computing. But we need to have further ambition. We know that advanced computing has serious issues in its ecological footprint, and therefore we launched the challenge that the installation of the Callium should also provide an innovative experimentation in terms of green supercomputing. And therefore, in close collaboration with the Minister of Environment, and I should acknowledge the deep commitment of Minister João Pedro Matos Fernandes in making sure that the installation of the Callium in Ave Park is done together, first in very close interaction with the municipality of Guimarães, and again I acknowledge and recognize the unique collaborative effort of President Domingos Bragança. Meu caro Domingos Bragança, reconhecimento sempre atual para toda a colaboração que tem prestado para garantir que o novo supercomputador será instalado certamente sob os auspícios do município de Guimarães, que será certamente um município altamente equipado, e agradeço a sua presença aqui também hoje, que mostra bem o commitment, mas também para que possamos no Ave Park, para além de instalar mais um supercomputador, fazê-lo de uma forma inovadora a nível internacional e a nível europeu. It is in this context that within the environmental plan of the Ministry of Environment, we are trying to make sure that implementation of the Callium is done together with the development of a renewable energy community at Ave Park, so that we can better use it provided by the supercomputer and try to give one step further in experiment and in demonstrating the way we can decrease the ecological footprint of supercomputing and in fact better use renewable energies. This is important because we know that there are different ways of doing. Even in Barcelona, there are tests undergoing of new embedded electronics in liquid means to decrease the way we use traditional air conditioning. But apart from advanced electronics, liquid embedded, we can also experiment in Portugal better ways to integrate supercomputing within renewable energy communities. And as we all know, this has been a very important strategy of Portugal within Europe to better integrate aeolic and hydroelectric energy in our electrical network. Actually, as you know, Portugal has currently the world record in number of consecutive days fully powered by renewable energy in association with our capacity to do this. Actually, most of this work is done at Inesctec, and again, I acknowledge also Rui Oliveira, the director of MAC, also a teacher at the University of Minho and a researcher at Inesctec that has been particularly active in this process. So there are technical issues, there are also regional issues and overall questions of funding. We will fight for funding. We need to be very creative. If today we have Bob, it has been associated with the capacity to negotiate, to articulate fundings, to articulate existing infrastructure, and never put new buildings ahead, but essentially using what we have and essentially trying to implement an intelligent strategy concentrated on the idea that public resources are always scarce, and therefore we need to move, but we need to be clever because we know that our most important resources is people. And this is my point, and my final point. Advanced computing is about people, people, people. It's about people in terms of usage, but it's also about people in terms of societal impact. So, and as you know, my strategy is always to dismiss the idea that we need to have more buildings, but essentially the idea that we need to attract more people to use and further use advanced computing. And this is our greatest challenge, to mobilize students, researchers, but society at large, and companies in particular, to further use advanced computing. And this is also a challenge for the Portuguese Science Foundation. Over the last 25 years, FCT and FCCN has been particularly oriented to provide infrastructure for science and for public research, and that should be the first priority. But now we are entering in a completely new generation in Portugal, in Europe, and in the world, particularly to mobilize the private sector. And certainly, within our context, we need to understand how can we articulate different funding sources, but also different users in the scientific, business, and in the interface world. And that is a challenge, also an institutional challenge, which should be associated with raising private funding, but open more and more the advanced computing infrastructure to the business sector. I know that Khalil Juana in Brussels is particularly active in this process to open the use of advanced computing to the business and social actors throughout Europe. And certainly this must be done in also an institutional context. What I mean by an institutional context is to provide the necessary legal and institutional context within our network of 4 major centers in Lisbon, in Évora, in Coimbra, and now at MAC, which will be the evolution of the institutional context so that we can provide our national network, RNCA, in a way open to public and business sector, in a way fully integrated with Spain in the Iberia network, but also very fully integrated in the European context of advanced computing. So again, I thank you all. This meeting is particularly important to listen to you, the users, to have your critical assessments, your opinions, your ideas, but above all, to have the ambition always to do more and more. Thank you very much.
Thank you, Professor Manuel Heitor. Now I welcome Nuno Feixa Rodrigues, member of the boards of Portugal's Foundation for Science and Technology, FCT, General Coordinator of INCO 2030 Program and Coordinator of Advanced Computing Portugal 2030 Strategy. Let's hear Mr. Nuno Feixa Rodrigues.
Excelentíssimo Sr. Ministro da Ciência, Tecnologia e Ensino Superior, Manuel Heitor, Sr. Reitor da Universidade do Minho, Professor Vieira de Castro, um agradecimento especial por acolher aqui este evento e por toda a colaboração no projeto e naquilo que é a Estratégia Nacional de Computação Avançada. Excelentíssimo Sr. Presidente da Câmara Municipal de Guimarães, também um agradecimento muito especial por toda a colaboração, não só a nível do Minho Advanced Computing Center, mas em todas as áreas de domínio da FCT e da investigação, que eu sei que tem colaborado muito através do município de Guimarães com aquilo que é necessário fazer pela ciência a nível nacional. Deputy General of DG Connect, Khalil Juana, Professor Rui Oliveira e Professor António Cunha, pivôs absolutamente fundamentais da Estratégia Nacional de Computação Avançada. Muito bom dia a todos. So, now switching to English, I will just give a brief note about the developments of the Advanced Computing Strategy. So this is a strategy we have started to develop about 1 year and so ago. And now I'll just give a brief presentation of the most significant developments that we have achieved in little less than a year. So the vision for 2030 is basically the same that we had about 1 year ago, is to pretty much align with the objectives of the European Union to create an advanced computing services economy involving all the major stakeholders in Portugal, industry, academia, SMEs and the public sector. And of course, to achieve this, we have to have advanced computing software and services, a thriving capacity in terms of advanced computing software and services, with particular emphasis on health, airspace, mobility, social and scientific development. These, of course, are just our major vectors of investment, but every area of development is pretty much welcome. Portugal is an advanced computing living lab, in this case in terms of having entrepreneurship and to promote new projects and new developments in Portugal, not just to follow and to implement and to study what has been developed abroad, but to collaborate internationally in developing these new solutions. And last but not least, and probably the most important, is to have the people vector, which is education and training, and to prepare these people not just to operate, but make the most and to extract the most value out of these resources. So, in a brief nutshell, this was the graph or the module that was devised about 1 year or so ago, and we put in the middle, that's in the center of the strategy, it's people, like the Minister said. Of course, we know that all of this has to be driven by people, particularly in Portugal, where we don't have capacity, industrial capacity for the development and the fabrication of microprocessors. So people is, of course, in the center of this strategy, but infrastructure is still necessary. Of course, we need to have people working on top of some infrastructure. And what we call infrastructure is basically the layer to connect these two things, is to provide the resources and the means so that the people can use the infrastructure, and in collaboration with collabs, polytechnics, universities, all the major stakeholders in Portugal, in order to produce what we need, which is better and more scientific knowledge and better and more innovation that can then drive economic growth and welfare for everyone. So, about a year ago, there weren't two of those spots that you see there on the map, actually MAC and Evra. They were already there, of course, but they didn't have any machines, any infrastructure. And now we have this is the backbone of the National Advanced Computing Network, with all these 4 major sites now working. So 2 of them, Evra and MAC, are now operating with supercomputers, and the other 2, namely LCA in Coimbra and Lisbon in ENCD, have upgraded their facilities and now have even better and more resources. So I'll just give a brief presentation of this, starting with MAC, the slide goes forward. So, and then Rui will provide some more detail about this, but this is our biggest machine, Bob, the part of the Stampede 1 that was given by Texas Advanced Computing Center in a partnership that was established about 1.5 years ago. So it's a 1 petaflop machine. It's our biggest supercomputing resource now operating in Portugal. And you can see it started operation in the beginning of, in July 2019. And it has been steadily increasing its capacity and providing this capacity to the scientific and innovation community. And of course, it will be now upgraded with Docaliant, and Rui will provide more details about that. But this is, of course, one of our major hubs in terms of the infrastructure for the advanced computing strategy. LCA, the Laboratory for Advanced Computing in Coimbra, this is one of our oldest facilities in terms of supercomputing, with a machine called Navigator with 85 teraflops, 164 compute nodes. And you can see it has quite some steady operation with many projects. As I said, this is our oldest infrastructure with already very good established partnerships in terms of using supercomputing for scientific advancement. There are some problems in terms of cooling. Now those are being taken care of, And the facility already during the strategy for advanced computing has been upgraded with 32 plus compute nodes and 1,280 new cores which are now available and providing the capacity to our community. ENCD is particularly relevant because it operates 3 different architectures. So we're not just talking about supercomputing, but also cloud computing and high throughput computing through grid computing as well. So this is quite relevant because many applications, or a significant number of applications, don't really need supercomputing and can, in fact, be used in terms of cloud and high throughput computing. And you can see in the graph the evolution and the usage of this infrastructure being growing along the time, with a significant amount now being put on high performance computing, but quite some balance in the last few months of this. And finally, Oblivion. This is our last supercomputing, entered into operation just in June 2020, so just a few months ago. It's 239 teraflops, so about a quarter of the capacity of Bob. And we still don't have numbers for this machine because it just entered the pilot stage, testing stage in June. Now, 50% of this project of Oblivion it was financed and supported by the Square Kilometer Array, which is a big research international project using radio telescopes all over the world. So 50% of the computing capacity will be for the data and the outcome of this great project. And the other 50% will be used for the network for national computing, which is operated by FCT. And I'll give a few words about that. So we have put operational in this last year through, and we have passed the internal regulation for the National Network for Advanced Computing, which joins all these 4 operational centers. So it formalizes and defines what is an operational center, which is one of the main elements of the strategy of advanced computing Portugal, and also competence centers. These competence centers are the interface centers between the operational centers and the facility and the researchers and the companies that need help, or at least that need some support in terms of using these highly complex resources, most of the times. So it defines the access rules to become an operational center and a competence center, and we have already received some interest from some institutions in Portugal wanting to become competence centers in advanced computing. Access committee to provide computing time and service provisioning as well. And very important was the definition of the regulation for advanced computing calls in order to allow FCT to launch these resources and combine these resources with other funding instruments that it uses. And not only the regulation was launched, but it was already put into work on the call, which was actually the 3rd call of a series of funding calls for projects on data science and artificial intelligence for public administration. And the 3rd of these calls was launched in April, already during the pandemic, and this call was direction to tackling pandemic scientific problems and innovation problems together with public administration. So this is a call that has a 3 million total investment for the entire scientific community. And it was the first call that we introduced the possibility, not only the possibility that researchers could apply for computing power, and for each project they could apply for 50,000 euros of computing power from the National Network of Advanced Computing, but they would also get a bonus in terms of evaluation of their projects. And this helped to drive some of the projects here. Now, of course, because we narrowed the focus of this program, we didn't get as much applications as we used to have in other editions of this call. But still, we got 14 applications. Most of them at this time went to Navigator. Here you can see the distribution. But they were already asking for, you see, for Navigator, 2.5 million hours of core hours, and also for Series A and for Bob. Oblivion is there, but it wasn't yet providing computing time. Following this call, we launched the first call completely dedicated for computing time, for computing resources. This was the first call on advanced computing launched by FCT in August 2020, We put into this call 27 million core hours, and we received 133 applications from 53 different institutions asking for 80 million core hours, which is almost triple the amount that we provided. I think this pretty much shows the activeness of our scientific community, mostly scientific community, because most of the applications we got was from research groups. And here you can see the distribution. The graph you see on the top left is divided in A1 and A2. A1 is for beginners, for people without experience, researchers without experience in advanced computing, asking for at most 2 months of computing resources and at most 500,000 core hours. So it's interesting to see that the majority, 71%, is from research units that already had experience and already was asking for quite some amount of computational time. In terms of the areas, you see 96 applications were from exact science and engineering, even though there are many different areas inside this, from mechanics to chemistry to biology. But we already see 17 from life and health sciences and 17 applications from natural and environment. And very, very interesting is to have 3 applicants from social science and the humanities. And this is very interesting. I don't have time to go through those, but it really shows that how important it is, this kind of resources for all areas of scientific development and innovation. Not so good is in terms of the gender balance of the applicants. We have 85% were male and only 55% were women. But I do believe that as we grow these resources and we bring these resources to more areas, we will see this gender balance probably getting more equal. So another relevant aspect is the project EuroCC, funded by EuroHPC, and this is directly to connect the people with the resources. This is a €2 million project for 24 months. It is coordinated by FCT, involves University of Coimbra, LIP, University of Minho, University of Porto, University of Lisbon, University of Évora, and it's really to put in place on the field these organizations to do the interface between these resources and the people needing them, particularly in terms of companies, public sector, and the research centers. So, and it will do with training and skills. This is something that we need a lot because we are really starting to implement the strategy, and we need more people in all the life cycle of advanced computing to be better trained and better skilled. Technology transfer, collaboration with industry, which basically resumes all the capacity that we need in competence centers. Also very relevant is the project funded through the UT Austin project, the big HPC project, which is promoted, and the principal promoter is a company, Wavecom, is an IT telecommunications company from Portugal, which is leading the project together with Inesctec, LIP, and TAC. And this is to develop software to do the management of these complex infrastructures, of these complex machines, and really to tackle one of the paradoxes that we see happening more and more, which is low utilization and high waiting times. And the reason for this, of course, is that these machines are growing and growing in size and being as ever more complex, and to have them up and running and to extract all the capacity and all the resources is really a big challenge. And this is something that we really have to invest on. This has outcomes not just for the network and for those 4 operational centers, but also for, of course, for companies and other institutions that have this kind of infrastructures and they want to operate them. And there will be more and more probably in the future. So there are many other things that have been going on in terms of funding of PhDs, in terms of working contracts for scientists and so on. And there's a lot of things going on, of course, in terms of cooperation, namely in the EuroHPC and all the European institutions. But this briefly puts in a nutshell, I believe, the most relevant developments. And I think the most important thing is that we are starting to see the response from the research community and even from our industrial tissue asking and responding to all these calls and fundings and resources that we are putting in place. Thank you very much.
Now let's hear the Minho Advanced Computing Center Director, Rui Oliveira.
Muito bom dia a todos. Muito bom dia, Sr. Ministro Manuel Leitor. Muito bom dia, Dr. Domingos Bragança. E, em nome do meu reitor, Rui Vieira de Castro, cumprimento os demais participantes neste encontro. O Minho Advanced Computing Center, algo que começou na cabeça do professor António Cunha há 5 ou 6 anos, tem sido uma viagem muito interessante, muito importante, a que eu hoje vou falar um pouquinho. I'm going to switch to English and also thank Khalil Rouana for all his help to the project and especially to be with us today. So, the Minho Advanced Computing Center from the beginning wanted to be a national advanced computing center, something that could bring us, Portugal, to the ecosystem of the international research and innovation in supercomputing, in HPC, but also looking ahead into all the data-intensive processing that was already lurking, and today it's a big necessity. In terms of the activities of the project, it was deemed to help or as an intervention in these 3 pillars or these 3 areas. One was the advanced computing research and innovation, but also as a support for the computational science and engineering, and also again on data-intensive applications and artificial intelligence. These 2 things usually walk together, but the idea that we have of a supercomputer center is usually focused on the middle one, on the support for the scientific community in terms of science and engineering research. But for Portugal, because of many difficulties that we have, mostly economically in the past, and the investment on expensive resources as the HPC requires, our research on advanced computing and innovation, so the research on the science of advanced computing, has been lagging behind. So there's these 2 goals of the project that needed to be addressed. And of course, there's it's pointless to do any research if you do not innovate, and if you do not innovate with companies that can actually take the value of your research and make it impactful in terms of economy and society. Oops. Oh, okay, sorry. Yeah. So it's important to understand the 5 pillars of the strategy. So the supercomputing center is not just a building hosting a big machine, a big, expensive, expensively maintainable machine. It's something that serves a purpose, serves objectives. And these objectives are somehow defined by these 5 pillars. One, again, is R&D in advanced computing. Okay? And here, it also supports what is expected from an HPC machine, which is research and development in computational engineering and science and artificial intelligence. That's the points I mentioned before. But to Portugal, especially to Portugal, if I had to pick just one goal, the main goal of such a project, that would be building capacity. We need to build capacity. We need to build human resources able to exploit and further develop the science behind HPC and data analysis and science. Then we also need such an infrastructure, such a public investment to also support public services and enterprises. And of course, you cannot do anything alone. You cannot do anything in Guimarães, you cannot do anything alone in Park or in Portugal. You need to be in the ecosystem. And actually, most of this journey has started internationally with the help from colleagues in UT Austin and also in Barcelona in BSc. And this is evolving rapidly. Okay, so what in practice, in a daily basis, what the Minho Advanced Computing Center aims is to cater to the needs of national research. And these, I'm not going through all of them, but I would say HPC, HTC, cloud computing, as support, as enablers of science, and then all kinds of digital simulation, which is what actually HPC traditionally does, and of course now data science. Okay? And everything that is made with that big machine needs to be seen, needs to be understood. And an important part of the whole MAC initiative, as well as the Advanced Computing Network, is a network of visualization centers. Okay, so in terms of the ecosystem, in terms of Europe, it was really important to position ourselves, and this was key to convince the European Commission to support us and believe us as a newcomer to this HPC ecosystem. We wanted to be a prominent node of the European pool of resources, resources that are growing by the day. We wanted to be a keystone in a strongly committed Iberian strategy, together with our neighbors, in particular the Barcelona supercomputing, but also closer ones in Galicia. We want to be a keystone in this Iberian strategy. Something that is also very important to the mission of MARC is to be able to gather all the data and be able to also curate it and process it of the Air Center initiative, a national initiative that is already congregating many countries along the Atlantic. And of course, we want to be dependable. We want to be a dependable partner in many projects that are not only Europe-centered, but internationally, which is already going on with the US, with South Africa, with South Korea, Japan, and Taiwan. Okay, and this started to be tangible, this journey started to be tangible in 2017. And for this, we had the help of the UT Austin, Portugal program, and in particular from the University of Texas in Austin. And we got, as you all know, part of what was the Stampede supercomputer of TAC, and this has been installed in Ribadav, and since then, this helped us a lot to reach what we already conquered today. So, oops, I'm sorry. Okay, so Bob was the tool that helped us to learn a lot, to learn fast with the help from TAC. and to bring together a growing community of HPC users that has been evolved since the beginning. The current operational system that we have, it's 60% of what we got from TAC. And the reason why is that Bob was already a 4 years machine. Not everything that we got kept working once we installed, and also because the Ribadav data center could not provide us all the resources, and this in terms of energy, but also in terms of cooling, to have all the system working. And part of what we got from TAC was decided to not be used, and these were the Xeon Phi coprocessors of the machine that would be very difficult to use from our community and very expensive to operate. Okay, so Bob has helped us to really learn a lot, to put together an infrastructure that is meant to be used by the whole community, and also to engage the cooperation and the help too of several SMEs in Portugal. And these are some graphs, you know, you cannot see very well from where you are, but the idea is that we have been growing, and if you grow, that's good. And this pie chart here shows you the many areas of knowledge that we have been servicing in Portugal to several researchers and universities around Portugal. Okay, and this was Bob. Bob actually helped us not only to serve the scientific community. This is very important. This is what it's more tangible. It helped us a lot to learn and to grow a small team of excellent people running the machine with all the problems that we still have, but running the machine and servicing the community, but also to some extent to be able to apply to a petascale machine in Euro HPC joint undertaking and convince our partners in Europe that, albeit newcomers, we could actually bring value to Europe and be a dependable partner. And this was very, very important in terms of our strategy and the way we design our strategy and our machine. So, in April 15 last year, we submitted our proposal to EuroHPC. In November 26 last year, we were awarded the Deucalion machine, and just some days ago, the contract has been formalized or awarded to the suppliers of the machine. I just put the date in parentheses because this is not actually the machine. The machine will be, so I will take out the parentheses next year when we can all go and visit the Deucalion. And as you know, we were one of the 5 petascale machines in Europe, and from 8 if we count with the exascale. So, going to the Deucalion. The Deucalion machine is different from any machine that has been awarded in EuroHPC, and is divided in 2 different architectures. One is what I would call a traditional supercomputer, similar to all the supercomputers that have been awarded in Europe. It has x86 architecture. It runs everything that is supposed to run to a HPC machine to run. So I would say it's the traditional part of it. And because AI and data science is very important these days, we could not have such a machine without GPUs. And so we have a small cluster of GPU-enabled nodes that will make the joy of many of our researchers. But what is different is the other part of the supercomputer. And there, we took, I would say, the bold move, and this was 2 years ago, to go to an ARM architecture-based cluster. And this ARM architecture-based cluster that we will be receiving next year is actually powering the most powerful supercomputer today, which is Fugaku in Japan. And this changes by the day, as you can imagine, but 96 or 97% of all the code that runs in x86 machines today is already running in Fugaku. And this is a many-core architecture with a major, with a key aspect in terms of programming. It is a general purpose architecture. So all the problems that the researchers and we, suppliers of the technology, face today with GPUs, just to give you an example, we do not have any user capable of using more than a GPU machine together. So all the workloads we have is on one single GPU, and at most 2 GPUs or 3 GPUs in a single machine, so we cannot scale out. This kind of problem we won't have with the new architecture, because this is a general purpose programming architecture. So I'll be glad to give you all the details about this. And in terms of agenda, we had to change this because of many constraints, but mostly because of the bastard that keeps us apart. We'll have the machine being installed, I would say, by middle 2021, and we expect to have the machine open to the public for at least for initial testing in the very beginning of 2022, hopefully by the end of 2021. And this will provide us a 5 petaflop cluster with x86 architecture, and then a 5 petaflop cluster with ARM architecture. Okay, so this is the overall Decollin architecture. So you see the 2 clusters, the x86 and the ARM cluster. And the x86 will be powered by AMD processors. Actually, we'll have 500 dual nodes with 64,000 cores with 128 terabytes of RAM. Then, included in this cluster, we also have a small cluster of 32 dual plus quad nodes of GPUs. These will have the newest NVIDIA cards that have been launched two months ago. And then the other cluster, the ARM cluster, will consist of about 1,500 nodes, 78,000 cores, and 52 terabytes of memory. But this memory, it's a very special memory because it's high bandwidth, just like the memory that we have in GPUs. Okay, and then we'll have a shared storage of 10 petabytes. So the timeline so we are just now signing and discussing the details of the contract. The Mac data center will be renewed or start be prepared early next year. We expect to have the installation of the new machine by the starting of the second semester of next year, and then by the end of next year, beginning of 2022, we'll have the new machine going on. Meanwhile, and this is very important again for capacity building and so on, is that during next year, from the beginning of next year, our researchers will have access to a cluster, an ARM cluster, exactly the same or with a similar capacity as the one that the Gallium will bring. Okay. Now, this is the current team of MAC. I'm not including here the great people of FCCN, because they are not actually MAC, they are nationwide, so I cannot reclaim the team for me. So this is just the MAC team. And Rui Miguel, there is the one that keeps everything going, and is with us today. And just to finish my presentation, we are hiring, okay? So please contact us. We need great people to work with many aspects of an HPC center, from the science also to the operation, to the image, communication, and so on. Okay, thank you very much.
Now let's welcome by video call the Deputy General Director, Communication Network, Content and Technology from the European Commission, Khalil Rouana.
No. Yeah. Hello, everyone. And I hope that you can hear me well. It's a real pleasure for me to be with you today for this event on Advanced Computing 2030 Portugal. Let me start by thanking you for associating us to this event, and a real big thanks for the organizers, but also a big thanks for the Portuguese authority. Many thanks for Minister Rita, many thanks, Manuel, for being a major contributor to our initiative on high-performance computing. Our effort on high-performance computing has been intensified since 2017 with the signature of the Common Declaration, where Portugal played a pioneering role in this. I know how important was the engagement of Minister Rita and the whole high-performance computing community in Portugal for making this initiative a real successful initiative. Our ambition was, and still, to make Europe a world-leading region in high-performance and advanced computing. And it is indeed, as Manuel said, when we launched it, there were a lot of doubts whether Europe can put its act together and collectively do the right investments in order to be a leading region in high-performance computing. We did that because we saw that our advanced computing and high-performance capacities, be it in terms of infrastructure, but also in terms of ecosystem for the development of new applications and for building such supercomputing capacities, were on the decrease side. And if we compared with worldwide, Europe came third and by far behind other competing regions in the world, the US, China, and Japan. Today, we could say that with the investments that we will be doing, or that we already committed to, in the next month, really it's a question of month, Europe will be the leading region in terms of supercomputing capacities. If we aggregate together the performance of these machines that we're going to buy together, Europe will be the world leading supercomputing capacities. will have the world-leading supercomputing capacities. The Deucalion is one of the 8 machines that we're acquiring together, and our total capacities through Deucalion and the other 7, our total high-performance computing capacity will be 7 to 8 times higher than what we had in 2017 or what we had in 2018 and 19 as well. It's so important. It's so important, not for having the technology only, but it's so important because today advanced computing and supercomputing can have a major impact on the way we address our societal challenges, but also our competitiveness, on the innovation capacity of our industry, and the excellence of our scientific community. This area that was confined to science and engineering, mainly the big users of advanced computing, we see it today bringing benefits to the widest range of applications and widest range of economic sectors. The COVID-19 crisis has shown us how important really can be the advanced computing to help us address the health challenges. And I could tell you from the experience we had with dealing with this crisis every day now, together with our colleagues in DG Sante and the health authorities in the member states, that we are at the beginning of understanding what advanced computing could bring to addressing the major health challenges, from personalized medicine to the tracking of pandemics, to understanding the behavior and the impact of the impact of our behavior and the impact of climate on our health system. And it is just the beginning. And we saw very quickly with really our relatively small project that we had on high performance computing, how fast it can be to accelerate the process for designing drugs and or designing vaccines. But just with a few million investment that we had with the help of the best supercomputing centers in Europe, we were able to bring pharmaceutical companies from around the world to test existing molecules against the genomic features of the virus. And very quickly, we were able to identify what are the molecules that could have major impact. They are now the molecules that are being tested from raloxifene to remdesivir, etc. And we saw that, in 3 to 4 weeks, you could do in terms of matching molecules what the medical community was needed 2 to 3 years to do. Supercomputing can help us address some of our major challenges. It's still at the beginning because just to take that example, we stopped at the identification, but when it comes to clinical trials, when it comes to inside trials, still the use of high performance computing, simulation modeling, artificial intelligence to accelerate these processes, as we do, for example, in the design of planes or cars, is still at the beginning. I mean, these communities are not used to use high performance computing. And this is why I say the opportunities are huge. This is just an example what we could do in health, just the beginning. The same thing when we look at environment and climate challenge, the simulation and today's capacity to analyze data, where the AI features that we're bringing into supercomputing enable us to understand better our environment, to understand better the impact of our behavior on the environment, the impact of our policies on our environmental development and on addressing our climate challenge. It enables us also to address and manage natural disasters in real time. These are just other examples, and I'm sure I'm preaching the converted because you're in this area. But just to say that what is important for us and for Europe, is not only to be world leading in terms of supercomputing capacities, but also in terms of using these supercomputing capacities across all our sectors. I mentioned just 2 areas of major societal challenges, but for our industry, this is a big boost in terms of innovation capacity, and we saw it in our high-performance computing initiatives with the first competence centers, and I think FTC is one of them. We saw how important will be the access of SMEs, smaller companies, in all traditional sectors to these capacities, how important for them to design new products, new processes, how important for them to be able to change business models. And that is really across all industrial sectors. And Europe can show the way in making the benefits of high-performance computing available to any business, anywhere they're situated in the Union. Hence the importance of what we're doing in EuroHPC. And hence really the importance of the impressive effort that Portugal has done in the last 2 or 3 years to be part and to be, a major contributor to achieving our goal of Europe, not only a leading nation in high-performance computing capacity, but a leading region in the use of supercomputing and bringing the benefits to the economy and society. This is a key pillar of our strategy for digital transformation, for the digital transition in Europe. It's a key pillar because we think that Europe should show the way in the way the digital transition happens by, as I said, ensuring that its benefits reach the widest, or reach all our citizens and the widest scope of our industrial sectors. This is why, that digital transformation today is one of the 2 key priorities for the Union, and making that transformation a success for Europe is a main target for the EU today. And that's why in the State of the Union, the President of the Commission for the first time a month ago announced important technological initiatives that Europe should engage in particular high-performance computing. She announced a big initiative on high-performance computing with an 8 billion euro of investments that we do for the future. I'll come back to that just in a few minutes. But just to say that we have progressed by pulling our act together. We've been able very quickly to come up with a joint undertaking. It's a record time. I think Manuel is used to this, and usually it takes us time to put in place initiatives of this sort, where we combine money from the EU, from the member states, combine money from different programs, from the regional funds, from the framework program for research and development, from the program for Connecting in Europe facility. It takes us time to do that, but for EuroHPC, because of the willingness and because of the effort really and the push by the pioneering group, the 9 groups, including Portugal, that helped us put this initiative, because of that, we're able to move very quickly, 6 months to put the JU in place, and in less than 1 year, we were able to gather €1 billion and engage already in tendering and acquiring the machine, establishing a roadmap how Europe could be a world-leading region in supercomputing capacity. It's really an achievement. And I can tell you within the Commission, EuroHPC is used as the benchmark today. It's used as a benchmark. How can Europe pull its act together and become a world-leading region in highly important areas? That's what we did together, and I'm really happy that we did that. And I hope that we'll continue. I think Deucalion is really an example, as was just mentioned in the previous presentation, of how we can create an ecosystem around high-performance computing. And I think in Portugal you're doing this excellently well with the networking of the supercomputing center, but also by all the ecosystem that you're building around it to encourage application development and to also build up the skills you know, we always talk about skills in Europe and the lack of skills, but we see that when you have latest technologies and you have a dynamic ecosystem around it, there's no problem. You maintain the talents, you attract the best talents, you create and enrich the ecosystem through these talents. And that's, I think, the way you're engaging, and it's really impressive. Deucalion is also, as was mentioned before, an example that in terms of mix of technologies, and it will help us to create an ecosystem around this next generation technology that will be low power, using main ARM processors, for example, that will be low power, and that would be more secure than what we have today. And that would also open up the scope of applications to a wider community. And we're so happy that also you're taking into account carbon neutrality and looking for renewable energy to feed the new supercomputer, and that you're embedding it also in a more strategic plan to reinforce Portugal capacity and, frankly, a major contribution to the EU-wide capacity in advanced computing. That ecosystem is essential. That ecosystem, supercomputing is the high end of digital technologies. If we master the high end, we're able also to build up the rest of the digital supply chain. For us, it's a key priority. I could tell you, for my commissioner, for the vice president, for the president of the commission, Europe presence in the key parts of the technology of the digital supply chain, from components to systems, to complete computing and communication systems, to the applications around us, is a key priority. We're determined to make sure that our digital transformation is a success. And for that, we need to shape the technology that it corresponds to our values, that it corresponds to the aspirations of our citizens, and it's with the widest outreach across all of Europe. It's really our goal, and that's why this investment is essential. When we master advanced computing, we're able to master the rest of the technology supply chain. That's why also we're engaging for the next financial framework with this initiative. I mentioned that the president talked about 8 billion euro investment. We will be able, from the Digital Europe program and from Horizon Europe, to bring together close to 3.5 billion euros to maintain our investments in high-end computing and in its applications and in the ecosystem around it. Essential. We will maintain our presence there. And we want to be, always bring at the leading edge, to bring these capacities to the fingertips of our scientists, of our engineers, and of our public sector administrations. So the 8 billion would include 3.5 billion euros that come from the EU. We hope that the member states can match, as we did now, the same amount, using also the recovery plan, which is now essential. I'll come back to that just in a few seconds. And but also regional funds, as we do for Deucalion, as we do for the supercomputing center in Barcelona, to which Portugal is a contributor as well. So matching the 3.5 billion that will come from EU programs, and we hope that industry could come in, mainly in the research, development, innovation, as well, to complete this whole investment, and we could reach an 8 billion euros for the next 7 years. This means 1.1 to 1.2 billion euros per year over 7 years. I think it would be an important amount and it would be an essential investment to keep Europe in the advanced computing arena and among world-leading regions. I think when we started this initiative, we were wondering whether we will be able really to bring in all member states around it. And sorry, and I come back to that, yes, sorry, one more time. I think the Portuguese participation from the beginning was also very important, showing the way that this could be all around Europe, that our investment could come all around Europe. And so that's, I think, our major achievement, our plans for the future. I think that the recovery plan, we are so happy that the member states agreed that they could invest 20% of the recovery fund, of the Resilient Recovery Fund in the Next Generation EU facility to digital technologies and their applications. And that could be digital infrastructures, could be the application of digital across all sectors, and there is a public interest, health, etc. And we think that this is a huge amount. We're talking about close to 130 billion euros across Europe that would go to the digital priorities. This could be an important opportunity to build up even further our high-performance computing capacity, complete what we do, upgrade our infrastructure, and look at these application areas involving all our engineers and scientists and diffusing the benefits of advanced computing across the economy and society. It's a huge opportunity. I really invite the member states to think thoroughly about these investments. That will help us to upgrade and step up our innovation capacity, competitiveness of our industry, and our capacity to address our key societal challenges. We are, I think, on a very good track, and I think that we have shown that all together, by acting together, Europe can achieve very ambitious goals. We now we need to make sure that, as I mentioned, these benefits go across all our citizens, reach all our citizens and businesses. In the EU, at the Commission level, we can draw plans, we can look for budgets, but the real work is done where you are. And if you think that we're not on the right track, if you think that we need to adjust, or even if they're good track, you could tell us, please, because without your work on the ground, I think all what we can do in terms of planning and investments will be useless. So let's keep this collaboration, and many thanks once more for associating us to this event. Thank you.
Thank you, Mr. Khalil Rouhana. Now we will be leading a debate with advanced computing users and operators. We remind you that you may submit questions by YouTube session. Discussing the topic are Irina Sousa Moreira from the Center of Neuroscience and Cell Biology of the University of Coimbra, Rita Gatch from the University of Lisbon, Joana Matos from University of Porto, and Rita Pereira from University of Minho. The panel debate will be facilitated by Nuno Feixa Rodrigues, Rui Oliveira, and João Nuno Ferreira, General Coordinator of FCCN.
Good morning, everybody. We are a little bit late, so I will move quickly to our guests, our researchers here today. And I would like to listen from you what is the relevance of this kind of resources in your past and current work, and what would you like to have in the future from facilities like MEC. And I will ask first Irina Sousa to make a speech.
So first of all, thank you for the opportunity to be here. I've been working with the HPC since my postdoc in Weill Cornell Medicine, in application with dynamic simulations. And then also with Surfsar and Utrecht University, I'm used to use it in PRAS too and Cineca. And I was always wanting to see the same kind of opportunity of using this kind of HPC in Portugal. And fortunately, this year we saw the opening of a few calls in Portugal for which I applied. So I'm very happy for that. In terms of what I think it's necessary, first of all, from a scientific perspective, I would like to see some kind of timetable of grants and calls every year that we can apply. I really enjoy the fact that, for example, when I applied to FCT call on AA COVID, we also had the opportunity to apply to the HPC at the same time, so it will be good for us, for example, that kind of establishment collaborator in the next FCT calls for not only this one but for all of them, of course. And for example, my group works in two different areas. One of them is very used to use this kind of infrastructure, and so it scales very well the software that we use. The other one, in which I use more application of AI to biomedicine with genomic and structural features, for example. We need more GPU access. I saw that now from this meeting that it's already there's already the idea of getting more GPU for the next few years. And for us, I think from the data science perspective and the data science perspective in biomedicine that uses terabytes of data, it will be very important for the next few years.
Okay.
Thank you.
Okay. I don't know if you want to make any comment on this. No? Well, and then we can move to Rita Gatch from Lisbon University. Okay,
well,
that's fine.
Good morning. Thank you for this kind of invitation. I'm from the University of Lisbon. I work in the Faculty of Pharmacy, and what we want in the Faculty of Pharmacy is, of course, to deliver new medicines to the society, to the patients. And what we see is that the drug development process is you need 10 years or more to have a new drug in the market. And of course, this is a process that can be speed using computers, using advanced computers, and that's what we do in what I do in my group. So we try to find new drugs, or it's not new drugs, but new drug candidates. We try to optimize molecules. We try to repurpose molecules that are already in the market and that we can use for other diseases, like Kyle Juan just was saying that we are doing that for COVID and we are doing that for other targets. But of course, our problem is always the equipment and the way to do that. We know what we need to do, but unfortunately, sometimes we don't have the equipment that we need to do it. So this kind of calls, this kind of opportunities to have this equipment is great. And like Irina just said, I hope that you are able to maintain these calls and these infrastructures for the next years, because we really need and we profit a lot from them.
Thank you.
Just a very few brief comments, and thank you for Irina and Rita for your observations on this. And just to say that it's on the plans of Advanced Computing Portugal, on the strategy to have a timetable where researchers and innovation can see when the calls will open, what is the expectation of resources that will be open. But we are taking the first steps. This is really the first calls. We really have to see how this works, how this computing power gets delivered and is used by researchers, but certainly that's a very important point. And another one, which probably Rui can ask better, is in terms of the details and the architectures. We do know that there are many different needs in terms of the computing power that is needed for different applications, even in terms of computer science and advanced computing, to just have the availability of the infrastructures to test new architectures are very important, but certainly GPU, not just GPUs, but FPGA, GPUs, and dedicated solutions are also on the strategy as well. But thank you very much.
So now I will ask Joana Matos from FEUP, from Faculty of Engineering of Porto University, to talk.
Good morning. Thank you for this invitation. I work in the University of Porto at the Associate Laboratory of Separation and Reaction Engineering. In particular, I am doing my PhD in the mixing group, which was founded about 20 years ago and is dedicated to fundamental studies of mixing for the development and optimization of reactors for new designs of processes that are sustainable and efficient. So mixing has a major impact in the performance of reactors in terms of costs and efficiency, and so our approach is to start from the quantification of the smaller mixing scales, which requires very refined grids for the CFD simulations, and this is why we were pioneers in the use of HPC at the University of Porto since 1997, and currently we use the cluster Avalanche since 2013. So once we have quantified the mixing scales from the smaller ranges to the largest ones, we need to implement the chemical schemes, which includes reactive systems, phase transitions, heat and mass transfer, and so once again HPC is required, especially because we deal with processes that need maximized heat and mass transfer, and this can only be simulated using HPC. One of the projects that we have at the moment is the Colab Net for CO2, which has the objective of developing a new process for the production of synthetic fuels with low pollutant emissions. This involves reforming hydrate formation for the CO2 capture and also combustion reactions, and is an example of our line of research, which goes from the quantification of the smaller mixing scales to the performance of 2D and 3D simulations of the chemical processes for the design and then construction of units. From my experience during my PhD, which is dedicated to combustion studies in the net mixed reactor, which was also developed in our group and is used in industry for the production of nanoparticles, which have applications, for example, in the medical field. And from this experience, 2D simulations only for the quantification of scales take about 5 days with the cluster Avalanche, which is the one we have available. And once the reactive system of combustion is included, they take up to 20 days. And unfortunately, with these computational facilities, we are not able to perform 3D simulations for the level that is required at the moment. And they are extremely important since they are the last step before the design and construction of the units. But luckily, I had a chance of using Bob. MACC team helped us to install the software ANSYS Fluent, which is the one we use for our simulations, and after that I performed 2D and 3D simulations. The results were extremely good. The 2D simulations took only about 16 hours, and the 3D simulations 26 hours. So in this type of investigation that requires a large amount of data and deals with complex chemical processes, we are dependent on advanced computational resources. One of our goals for the future is to be able to simulate at a molecular level. Right now we are at the mixing level, which has scales between 10⁻⁴ and 10⁻⁶ meters. But once we move to the molecular level, we will simulate scales in the order of 10⁻⁹ meters, which will enable us to have simulations not only of the chemical processes, but also of the composition of the products. And so if we want to continue in the front line of this type of investigation and be able to provide new solutions that can contribute for our future economy and sustainability, we are dependent on HPC since the kind of chemical processes that we deal with are very demanding in terms of computational resources. And thank you for your attention.
Thank you very much. Yes, Troy, please.
So thank you for explaining us all the simulations that you've been doing. What would be the requirements from net2mean and the new project on the new hydrogen?
Yes, the problem is that with the computational facilities that we have, we don't have enough nodes for the simulations. Right now we perform 2D simulations of the chemical processes, and the simulations take larger time than we wish we had, because this project is about 3 years, and in 3 years we cannot take about 20 days to have the result of one simulation. And after the 2D simulations, we need to perform 3D simulations because they are the closest to the real reactor, so it's easier to understand the physics of the process in 3D. In fact, in our case, our reactor, since the reactions occur mostly in the 2D plane, we have a good approach with 2D simulations, but obviously it's better to perform 3D simulations. And with the cluster that we have, let's say the rule is that each simulation that is submitted only has available 2 nodes, each one with 16 cores, and that is a problem. For example, with Bob, which was the one I've used for the simulation tests, we had available 9 nodes with 16 cores each, so it's a large difference in terms of computational time.
So one thing about this project is that for dynamic fluids, Mac typically tends to use open source software, and for dynamic fluids, our choice of election is OpenFOAM, on which we're getting a lot of experience and a large group of collaborators. It happens that the group of Rita is not using OpenFOAM. It's using a commercial software, which is
it's ANSYS Fluent.
It's ANSYS Fluent,
yes.
The good thing about ANSYS Fluent is that it's very, very well supported in the new architecture of the Oblivion, in particular with ARM. So we foresee a great increase in terms of capability in terms of this.
And so now I would pass the microphone to Rita Pereira from Minho University.
Thank you thank you for inviting me for here today. I would like to greet all those presents. So my contact and my experience with Mac cluster happened during development of my master thesis in biomedical engineering, which was hosted by the Institute for Polymers and Composites, and with international company partnership. In more specific, my work focused on computational simulation with OpenFOAM, and I think the opportunity to assess I had to assess Mac was very important, very useful for me and for my study. Because the computational model we develop is quite complex, and for this you need several computational research for study. I can make a sample calculation in terms of the time simulation. With different research. If I run my simulations with a computer with 8 cores, I need 40 days to get results. In another hand, if I run simulation with Mac cluster with with 48 cores, I need just 3 days to get results. The final conclusions of my master thesis consider 12 models, computational models, and for this I need 10 more a year to finish my master thesis. In terms of my overall experience, I think its user interface is very accessible and quite simple. Over time, I had all support for installing the software and the solver, and thank you for that. For the future, I note some news about visualization tools remotely, and I really appreciate this because these tools is very important for my activity. Because, for example, I need, in my case, I need a day to export data to analyze later. I would like to conclude by saying I consider the access and the investment we make in this computational research most important to simulate a more complex system and system interesting for industry. For example, in my area, biomedical technologies and applications based on computational modeling and artificial intelligence. And for that, it takes more and efficient computational research to simulate and to obtain results as quickly as possible. And that's it. Thanks.
Thank you very much. I don't know if you want to make any comment. I'd just like to say that the integration of artificial intelligence with the classical HPC processes is a clear trend that we see coming stronger and stronger in the last few years. So to have HPC processes working very closely with artificial intelligence process working very closely with HPC processes.
Yes.
And maybe your case is exactly one of those that you need both technologies.
Yes.
We have received one question through the YouTube channel from Pedro Diniz, and I will read to you and I can answer because I think I know more or less, although it's a question to European Union, but the question is from Pedro Diniz from INESC ID, is how is European Union envisioning the inclusion of HPC as part of the infrastructure itself, for instance, in supporting autonomous mobility and preparedness for dealing with situations such as COVID-19. I can say that in the proposed papers for the big funding programs of European Union, namely the Digital Europe program, there's this idea of a computing continuum. So what is proposed by the Commission is a computing continuum where we have the concentrated resources, that's the HPC sites. For example, in EuroHPC we only have 8 sites, 3 pre-exascales and 5 petascales, like the one that the Kalin belongs. And then we have this middle computation that now is being defined as cloud computing, and then you have also edge computing, and this should work from the edge to the HPC center in a continuum. Of course, this is not the reality today. New software must be developed to make everything work as integrated resource. And that's it. I don't know if Rui or Nuno would like to make any further comment.
Just a very brief comment, and I took very good notice of all the suggestions that you have been providing. Also to acknowledge and we knew that software, the middleware, the software layer in terms of the access to these resources are also very important. And the heterogeneity of the solutions that are now coming into appearance, and depending on the applications, not just HPC's typical and traditional supercomputing for simulation, but also high performance for data analysis, even high performance for embedded computing, like Jonan was saying, to implement this continuum, this computational continuum. And I think there are many opportunities there, and we certainly have to have also the infrastructure to provide this for researchers to continue. So, and this is something that we will be looking forward in the strategy.
Okay, just to thank you all as users. Everything that we put together in MAC is for the users, and it's really great to hear that we've been of help to bring young researchers to the HPC environments. That's one of our missions. Bringing you to the ecosystem and to the programming environment also helps us to learn how to bring the industry, because it's much more difficult to do. So this is a journey. We are just in the very beginning, and we need everyone to actually use and help us to better serve. And again, as I had in my last slide, we are hiring in many aspects of the MAC operation. So let us know if you're interested. Thank you very much.
Okay, thank you. And now I think we can move to the closing of this event.
For the closing remarks, we will hear again by video call Portugal's Minister of Science, Technology and Higher Education, Mr. Manuel Heitor.
A todos, penso que agora poderemos falar português, que eu saiba não está ninguém, pelo menos ligado em Bruxelas, e eu tenho uma palavra apenas de reconhecimento e também de grande ambição para aquilo que aqui ouvimos. Naturalmente, há uma comunidade crescente, não é nova, este assunto nasceu há mais de 20 anos em Portugal, mas não há qualquer sombra de dúvida que o dinamismo que conseguiu ser estimulado, implementado e posto em prática nos últimos anos é particularmente importante. Como veem, as estratégias funcionam e o facto de termos, por um lado, dinamizado no contexto europeu a Declaração de Roma em 2017 e depois, a par disso, criado uma estratégia em Portugal, naturalmente no contexto da relação da FCT com a comunidade científica, foi particularmente importante e por isso agora temos que continuar a fazê-lo. Temos um objetivo grande de introduzir o Deucálio e de cada vez mais construirmos a nossa infraestrutura, capacidade e utilização de computação avançada num contexto europeu. Eu não ouvi nenhum comentário sobre a ligação, particularmente à Espanha e àquilo que chamamos a RICA, a Rede Ibérica de Computação Avançada, mas penso que este é, mais uma vez, um contexto perfeitamente crítico. Naturalmente, desenvolvermos as capacidades nacionais, mas sempre percebendo a integração, neste caso com Espanha, e certamente depois sempre a nível europeu. Isto é importante a vários níveis. Por um lado, para nos estarmos sempre a comparar. Se é verdade que já temos, sobretudo, um conjunto de 4 infraestruturas distintas em Portugal, portanto, a infraestrutura com a sede em Lisboa, no LNEC, Coimbra, Évora e agora no Minho. É verdade que a comparação entre elas e a diversidade é importante, mas naturalmente temos de estar sempre a comparar com os outros e obviamente é natural que a nossa relação com Barcelona seja não apenas promovida, mas também como um estímulo para estarmos sempre à frente e sabermos aquilo que o supercomputador de Barcelona, que é um centro de reconhecida credibilidade internacional, está a fazer, de forma a podermos dar acesso aos nossos investigadores, mas também seja uma forma de estarmos continuamente a compararmos com o que estamos a fazer e podermos estar sempre na linha da frente. O mesmo, naturalmente, também com os restantes centros europeus. Sabemos que a principal fonte e infraestrutura de supercomputação ainda usada por muitos cientistas portugueses é Barcelona, e por isso é bom esse relacionamento, mas é importante também não apenas concentrar a utilização na nossa infraestrutura nacional, que deve naturalmente ser desenvolvida, mas estarmos sempre a estimular a utilização por portugueses das infraestruturas na Europa. Isso dá-nos mais Europa, dá-nos mais acesso, dá-nos mais comparação e podemos estar sempre a perceber como nos comparamos. Como é óbvio, o desenvolvimento científico e industrial português foi sempre e sempre será em estreita comparação com os outros e com aquilo que de melhor se faz na Europa e no mundo. É também neste contexto que obviamente desenvolvemos há uns anos atrás, há mais de 10 anos, a ligação à Austin, e hoje sabemos bem os benefícios que temos recebido dessa ligação e cada vez mais os benefícios que podemos receber no fundo. Foi interessante ver na apresentação do Nuno um dos projetos mobilizadores que está a ser financiado também com fundos comunitários e fundos nacionais no âmbito do programa UTI-Austin Portugal, que, para além da atividade científica, traz também uma empresa no desenvolvimento de novas metodologias e sistemas de gestão e operação da supercomputação. Como sabem, penso que nesta área o futuro da supercomputação passará cada vez mais pelo movimento de sustentabilidade crescente e, portanto, tudo aquilo que hoje se chama por Green Supercomputing e o desafio de integrar no AVPARC uma comunidade de energia renovável é particularmente crítico, porque as nossas sociedades não poderão tolerar de forma alguma a evolução daquilo que tem sido a pegada ecológica dos supercomputadores e, portanto, isso hoje é perfeitamente claro que passa por novas soluções, quer ao nível da operação das máquinas, mas também da sua instalação mais sustentável, a par daquilo que é o desenvolvimento de novas eletrónicas com esquemas diferentes de arrefecimento. Naturalmente que por trás de tudo isto está a ciência e por isso a computação avançada é também, para além da sua própria área científica, é uma ferramenta para se fazer mais e a melhor ciência. Foi particularmente importante ouvir os mais variados casos da mecânica dos fluidos, à física dos plasmas, como vimos, aos materiais avançados, às aplicações em biogenética e, obviamente, esta é uma questão crítica, estar sempre a associar os desenvolvimentos da computação avançada com desenvolvimentos e aprofundamentos concretos do conhecimento científico. E este é o desafio que eu deixo, certamente à FCT, ao Nuno e ao João Nuno Ferreira e também ao Rui Oliveira, mas também aos coordenadores do INCD e do LCA, que no próximo Encontro Nacional de Computação Avançada, que eu sugiro que seja realizado nos próximos 6 meses e no contexto da presidência portuguesa, nos foquemos muito nos desafios científicos para os quais a computação avançada é perfeitamente crítica. Penso que pode ser particularmente importante ainda durante a presidência portuguesa e por isso talvez já dentro de 7 meses, em maio ou junho, esperemos já com maior tranquilidade no combate à propagação da pandemia, possamos organizar uma reunião com a Comissão e juntando as 8, e juntando em Portugal, trazendo em Portugal as 8 máquinas peta e exascale, portanto as 5 petascales, como o Leucalium, e as 3 exascale. Esse é um desafio que eu deixo ao Rui Oliveira e ao Nuno Ferreira, para começarem certamente em colaboração com o Khalil. Enquanto estávamos na reunião, eu troquei já algumas mensagens com o Khalil, para, eventualmente, entre maio e junho, tentarmos fazer um workshop com as 8 principais, ou responsáveis, ou líderes associados às 8 principais máquinas europeias, e, obviamente, trazendo cientistas para fazermos um diálogo de alto nível sobre aquilo que pode ser os padrões de evolução da computação avançada na Europa. Esta reunião pode, obviamente, melhor posicionar Portugal, certamente o MAC, mas, de modo geral, a comunidade científica portuguesa no contexto da Europa, e chamar a atenção para o bom trabalho que se faz em Portugal. Deixo-vos este desafio e, mais uma vez, agradeço e, obviamente, desejo um bom almoço, certamente de base minhota. Muito obrigado a todos.
Thank you, Mr. Manuel Heitor. Thank you all for being with us. We wish you all a great day and a wonderful weekend. I invite you all for a quick lunch, which will be served outside the auditorium. Thank you all again. See you next time.